Good afternoon. This is Dr. K. Balasubramani from Department of Chemical Engineering in Hindustan College of Engineering and Technology. Today we are going to discuss about the petroleum refining products from various petrochemical industries and the petroleum sector. Next we see the what are the petroleum products can be obtained. The crude petroleum must be separated into enormous number of products to achieve the maximum economic return. It's nothing but of the worldwide market for productions and also uptaking capacity also. A portion of the separation takes place in the oil field where natural gas, liquid petroleum gas and the natural petrol are removed before the remainder of crude is put into the pipelines or tankers for shipment to the one movement to the another movement is nothing but of one place to the another place from the refineries. The flow sheet shows the operation to produce all the products of typical refinery. The suitable classifications of the product is listed. The flow sheet which represents the refinery operations, how the feed can be taken and what are the output can be produced. The crude oil is taken as a feed material here sent for the advanced distillation unit. Before that, the pre-treatment of desalt can be appear, the removal of water particles and the salt materials. On the down portion having the residual, obtain the residual can be attached by the vacuum distillation. From the vacuum distillation, there is a n number of products can be taken by using the thermal cracking and also visc breaking, the propane desalting. Before that, that is the middle distillate, the petrol, solvent naphtha, kerosene, gasoline, lubricating oils also. And the above light distillates are by recovered by using light gas recovery. It's nothing but of methane, ethane, propane, butane, pentane, heptane, hectane, fuel of synthesis gas. And second product is the C3 to C4 saturates is the LPG fuels of synthesis gases. From that also there is the isomerization process, catalytic isomerization process. There we can change the light polymer C6 to C9s, and also from the byproduct of detergent manufacture is nothing but of sulfated detergents. And next is the alkylation takes place by cascade method and the sulfuric acid method. And also the middle distillate deals among the petrol low grade sulfur removals and also catalytic reforming. From this the byproduct of ammonia recovery. And the intermediate of solvent naphtha and recover also kerosene, gasoline oils from when recovered by the catalytic cracking, petrol treating and the blending to the productions of petrol or motor fuels, and also having the domestic heating oils. Let's see the briefly among the petroleum products. Next, first one is the gas fractions. The gas fraction is the gaseous fraction previously used only for the fuel materials are now shifting in the usage to preparations of synthesis gases. Natural gases largely methane with some C carbon are separated at the well. Next, the light gas from the distillation of petroleum crudes, the refining of C1 and the C2. And also the off gases from petroleum conversion operations, at refining hydrogen sulfate, sulfur dioxide, carbon 1 to carbon 14 and also carbon 2. The LPG as a propane and butane liquefied for domestic fuels entering the gasolines of the synthesis gas. Next we see the light ends from petrol or motor splits. Petrol is the principal refinery product, and most of the chemical conversions like alkylations that are at the refineries aimed at maximizing yield of various grade of petrols. This fuel is as an energy source for piston engines and gas turbines is formed to meet engine combustion for the required. Next we see the combustion characteristics of petroleum. The high compression causes the violent detonations of knocking properties. First of all, we can see the characteristics of petroleum knocking properties. Next, it is the anti-knocking compounds added to slow down the burning rate. To reduce the burning rate, lead tetraethyl isoparaffin, lead tetramethyl ring unsaturated, and the properties of anti-knocking rating is terms octane number is an arbitrary scale based on the percentage of octane number 2,4 trimethylpentane in a N-heptane, which will avoid knocking when tested on a SAE standard engines. The commercial petrol blends usually used mainly in aeroplane pistons engine have better knocks resistance than the iso-octane, that is octane number greater than 100. The scales is extended to arbitrary power is proportional to the power extractor. Next, the productions of petrol. First one is the natural petrol, second one is the refinery motor split. The natural petrol recovered the oil field by absorbing in a gas or straw oil in a stripping of natural gases used for winter blending. The refinery motor split produced by blending from various refinery concentration process to give the correct octane number and other characteristics also. There is also solvent naphtha and kerosene now used for jet fuels and the reformation of reformate stocks in addition to previous requirement for heating and solvent. Next we see the intermediate distillate. First one is the heavy fuel oils, diesel oils, gas oils at low. Next heavy distillate. There is an intermediate distillate and compared to the heavy distillate. Mineral oil, flotation and floating oil, wax, lubricant oil, etc. Next we see the what are the residues can be present in the crude, lubricants, fuel oil, grease, petroleum, asphalt, road oils, petroleum cokes is nothing but of aluminum plants and electrodes, and also they have in the byproducts of detergents, ammonia, sulfur and derivatives. Next we see the characteristics of refinery. From the characteristics of refinery, there is the three types. First one is the primary refinery, intermediate refinery and the complex refinery. The primary refinery talks about the simplest refinery consisting only of a distillation unit to produce residual aspects and the shell for all overhead to the another refinery. The intermediate refinery talks about the produce motor fuel, distillate fuels and residual typical of European nearest with the petrol demand related to the heating fuels. And the last is the complex refinery. It can be shown already shown in the figure. There is a difference among the products. How can we get the feed and what are the byproduct can be present. Next is the design of refinery. It is an independent unit operations still from 1950. All the refineries were built with holding capacity between any unit could be operated, shut down and reconditioned independently. Next is the integrated operations. The integrated refinery can be built with 20 to 30 investment saving. It is defined with little hold up capacity between, since refinery maintenance requirement can be reliably scheduled. Next is the choice of crude petroleum. The first talk about the refineries are originally built to handle certain types of crude oils. Next is the two refineries at Bombay handle Middle East crude. Decision to handle other types of crude involves refinery changes. For example, Venezuela crude and having the high salt and sulfur impurities to remove before for the conventional purpose to the environmental source. There is a large refinery may be several types of crudes and process then can be separately. The crude oils which produce supervisory distilled fuels may be separate from those yield principally for the stocks and the asphalt. Next, the refinery process. The refinery process can be obtained from physical changes. It's nothing but of an anomalous refinery product. There is a two major difference. First one is the physical changes or unit operation. First, distillation. We talk about the distillation. Separation based on relative volatilities, most importance of all refinery operation. Second one is the absorption. Separation based on relative volatilities uses curve out high boiling fractions in low concentration gases. Next is the extraction. Separation based on relative solubilities in different solvent used primarily in lube oil manufacturings. Next, compared to the absorption separation based on relative adherence to surface of solids, color removal, separations of saturated from unsaturated. Next one is the crystallization based upon different free radicals and difference used in the wax preparation. Next one is the heat transfer. Energy can be transferred from one moment to the another moment. It's nothing but of conduction, convection, radiation. The energy conversion is a primary design requirement with sample use of heat exchange. Next, fluid flow. From the usual single phase fluid flow of fluids and gases and important applications of two-phase flow in gas, solid catalytic operations of the moving bed and the fluids bed type. Other unit operations of chemical engineering are used as a lesser degree. Next we see the chemical changes or conversion operations. The first, there is a unit process used for the petroleum industry to produce highest value in product. For example, the fractions of crude petroleum existing in petrol molecular range C5 to C6 is only 25 to 40% depending on the grade of crude. Next, even the arrangement of these molecules is unsatisfactory for current petrol requirement, since the current refinery output of high quality petrol may be as the 50% in the US. Numerous conversion processes are used for the accomplishing the upgrading. Next, the India process conditions are set up by maximizing the kerosene diesel oil product yield and reduce the petrol yield. In addition, the excess naphtha which accumulates is being converted by steam cracking to fertilizer and petrochemical starting chemicals. Last, the reforming and the hydro dealkylation operations are used to produce primary aromatic chemicals, particularly benzene. Next, the summary of refinery conversion operations is listed there. Next, with detail for some of the section is below. First one is the pyrolysis and cracking operation, hydrogenation, reforming, sulfur removal, polymerization, alkylation, isomerization, hydro dealkylation, hydrogenation, and next is the sulfur removal. Okay, thank you.